Hi everyone, this is the third video for section 2.2, 2.3 whole numbers and numeral systems. So I had two more of the numeral systems just to go over. So the other two of the other examples in section 2.3. So the Mayan numeral system, so this one, you see we have different symbols for 0 up to 19. So can you guess what base this is? So remember that in the number system that we use, the European number system, we have different digits for 0 up to 9, and we are in base 10. So when you have different digits for 0 up to 19, that means that this one is base 20. So this one has different symbols for 0 to 19. Notice this one does include 0. So this one is a positional system. So positional system, right, is defined right here. So a positional system is a system in which the value of a digit depends on the position of the place it occupies, right? So we use our normal European system is a positional system because we have different places, right? Our place value system. So the Mayan numeral system is positional, and so this one's actually written vertically. You can see an example of this, example 2 on page 60. So now let's look at this Egyptian numeral system. So this one, you can see, is additive. So it's additive because you have 1, you duplicate that symbol to get 2, then you add another one to get 3, and so on and so forth. So this is an additive system. So it's not positional. And you can see that this one is base 10 because we have a different symbol for 1 up to 9, and then each power of 10 has a different symbol, right? So all of these different powers of 10 have a different symbol. And then we add all of them up. So this is additive. So it's a system in which the value of the number is the sum of the values of the numerals. And in this case, the numerals, right? A numeral is just a symbol. So in this case, these symbols, which we more often think of pictures in this Egyptian numeral system, just represent the number based on the sum. So we want to identify which of the above numeral systems are positional and which of them are additive. So we're going to have a list of positional. And we're going to have a list of additive. So I have talked briefly on some of them if they are positional or additive, but at this point I encourage you to pause the video and go back and see if you can remember which ones are positional, which ones are additive. Okay, so we've gone through, and anything where the numbers having a different position makes a different place value, those are the positional systems. So the positional systems are the Arabic Hindu numeral system, right? That one that we started with, so Arabic Hindu, where that one's base 10. We have the different numerals for 0 through 9. That includes the standard European system that we use here. So then we also have the Babylonian numeral system, right, that was base 60, and we had the example of what 2 looks like versus what 61 looks like. So that one was also positional. So the Babylonian system. And lastly, the one we just talked about above, this Mayan system, is also positional, written with the position written vertically. So what was additive, right? So we have this Egyptian one that we just talked about that was additive. And also Roman numeral, or the Roman numeral system, right, was also additive. Okay, so we just identified which of them were additive and positional. Yeah, pretty simple. Additive, you just add everything that's there. Positional, the position that the numeral is in changes the value. Okay, so now we're going to go more into these bases that we've talked about. So we've seen an example of base 10, which is the system that we use, base 60, base 20, but there's all different types of bases for pretty much every number, right? We can always have a base B numeral system, is a positional numeral system based on powers of B, where B can just be any number. So we're going to look at some examples. So we've seen, right, some of these examples for 10 and 20 and 60, but let's look at some that use the European digits, but have different bases. So the place values for a base B system, right? So we have that we start with on the right, this B to the 0. So this is in our traditional base 10 system, this is the ones place. So this is just, in all of these, B to the 0 is just equal to 1. So this is always the ones place. Then we have the B to the first power, so B to the 1, that's the B place. Then we have B squared, B cubed, and so on, right? So this in our traditional base 10 system is the ones, tens, hundreds, thousands, and so on, where that's 10 to the 0 is 1, 10 to the first is 10, 10 squared is 100, 10 cubed is 1,000, and so on. And we can just do this instead of using 10, any number B. So let's look at some examples. So let's look at base 5. So base 5 has the different digits 0, 1, 2, 3, and 4, right? So if we were in base 10, we would have digits 0 through 9, right? Up to, but not including 10. And it's the same for base 5. We have 0 up to, but not including 5. And we can have different numbers here, right? So based off of this place value system that we just went through, we have these digits and we have these numbers. So right in our things that just have a ones place, we have 0, 1, 2, 3, and 4. But now, these are all of our possible numbers that just have value in the ones place. But now we look at things that have value in the ones place and the fives place, right? This would traditionally be tens, but since this is base 5, it's the fives place. So now we can have things that look like this, that looks like 10, but it has value 0 plus 1 times 5. So you can see this. They do an example of this for the Mayan numeral system, example 2 on page 60, and also the binary and hexadecimal numeral system. So definitely check out page 60 to see examples of this in the book. So we have a 1 in the fives place and a 0 in the ones place. Then we can have a 1 and a 2 and 3 and a 4. But once we get to 4, we carry, right? Just like how when we deal with base 10, when we get to the 10, we carry here. And this just keeps going on. We can have this pattern continually in base 5, just like we do in base 10. So this was an example of a base that is smaller than 10, right? Where that one is a little bit more simple because we have all of the digits that we would need. Because 5 is smaller than 10, we just use the digits up to 5, and those are all common in our European system that we use. But now, let's look at a base that's bigger than 10. So if we look at base 16, well, this one is called the hexadecimal numeral system. It's pretty common, and it has these digits. So we have the same thing, 0 to 9. Right, we have 0 to 9, but now instead of writing 10, 11, 12, 13, 14, 15, 16, we instead go to letters, where 10 is represented by A, 11 is B, 12 is C, 13 is D, 14 is E, 15 is F. So we have digits 0 through 9 and A through F. And so these are some numbers that we have. So just like before, we can have all of the numbers that only have value in the ones place. So that's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, and F, right? All of the things that just have value in the ones place. But now we changed to have things with value in the ones place and the 16s place. So we're going to keep going exactly like before. Now we also have what looks like 10, but really has value 17. I'm sorry, but what really has value 16. And then we can keep adding a 1 in the ones place. And then we keep adding 1 in the ones place. So we get 1A, 1B, 1C, 1D, 1E, 1F. And then we keep going, right? Once we get to F, we carry. And we just keep going like this. Okay, so these are just a couple examples of a base B numeral system. So we're going to be dealing a lot with operations in base B. So I would definitely get comfortable with different bases. This may seem really confusing at first, but I encourage you to just read all the examples in the book and go through the homework. And if you have any questions on this, as always, email me, come to office hours. But this is just a few first examples of a base B numeral system. So that is all for this video.